let's get started if that's, I know it's tough coming right after lunch, so, I promised Doug Novacek I wouldn't sing, to get us started here. But we want to welcome you all to our panel, New York, the interface between science and offshore wind policy in a dynamic ecosystem. I'm Howard Rosenbaum, and I want to thank my co-conspirators, Dr. Mindy Rekdahl, Dr. Mark Baumgartner, and Dr. Jen Dupont. We have what we hope will be an informative and interactive panel where I'll give some framing remarks, and then we will have three short presentations that will then follow with a panel discussion. So I'm Howard Rosenbaum. I direct the Ocean Giants program, which is our global portfolio at the Wildlife Conservation Society. For those that may or may not know about the Wildlife Conservation Society, we are headquartered here in New York. We own and operate in partnership with the New York City, the 4 zoos, and the New York Aquarium. We also oversee a global portfolio of work to protect wildlife and wild places in more than 60 countries around the world. And next year we'll be celebrating our 130th anniversary. And it's the actually 125th anniversary this year of the Bronx Zoo. So, feel free to come visit whenever you have the opportunity. I'm going to pivot quickly to set the stage for my co-panelists here. So I think it goes without saying that the New York Bight, the waters off of New York and New Jersey, are a really interesting and diverse ecosystem for charismatic marine megafauna, and we're going to be focusing in on cetaceans today, from the nearshore waters all the way out to the outer continental shelf and canyon regions. The diversity of cetaceans ranges from small cetaceans, harbor porpoise, to many of the large whale species. And the focus of the work that we're going to be doing is to present how some of the data collection in Empire Wind since 2016 is being analyzed, the data that are informing decisions using the passive archival data, but also some of the near real-time components, and tying that up into best practice that Equinor is using. So that focuses in on Empire Wind. I don't know if you can see this here. These are the 2 buoys that the Wildlife Conservation Society, in collaboration with Woods Hole Oceanographic Institution and supported by Equinor, have been maintaining. I also pointed out, just for reference purposes, the other lease areas that are in the New York Bight, where we are funded by NYSERDA, and we want to thank all of the developers that contributed information we worked closely together with over the last months to deploy archival units in each of those lease areas. So thanks to all the offshore wind developers that made that possible, and to NYSERDA for the funding of that effort as we build up the pre-construction baselines for this region. To set that stage also, I think it goes without saying, you've heard this in a few different talks, before we even get into offshore wind construction and operation, large whales and cetaceans in general, face a variety of potential impacts and threats in this environment, from noise, ship strikes, entanglements, both seen in, individually, cumulatively, and in synergy. We also have the open unusual mortality events for 3 of the large whale species. And for example, we know that the humpback whales that have been necropsied, have 40% of those have some human interaction. And we know that those impacts, again, there's lots of different slides that have been shown and ways to think about this. There are consequences to the individual that can then have population and species level disturbances, and the impacts to habitat can also filter through the populations down to the individual. So I'm not going to go into detail about these systems. Mindy's going to talk quite a bit more about that, but the one thing I think that's really important when we think about the work that WCS and WHOI have done collaboratively with Equinor here and supported by other foundations prior to the collaboration with Equinor, is that the work that we have in terms of the near real-time systems that WHOI has developed have been in place since 2016. And this is really a truly remarkable data set in an offshore wind lease area, both for the near real-time and the passive archival analysis. And just to give you a sense, you can see how long these buoys have been operating, more than 2,600 days with over 25,000 detections of large whales. So it's really a robust data set that's continuing pre-construction, through construction, and then after construction as well. And just to point out, because we're not going to get into too much detail about the near real-time aspects, but they are really fantastic in terms of how they can be used both for public display as well as for applied conservation. You can check out any of these, the detections and sliding windows and vignettes that you can play with yourself and check out through Mark's website at Robots for Whales or our website at whalesofnewyork.wcs.org. And then there's also a kiosk at the New York Aquarium where you can actually see this in near real time and see those detections as well. The applied nature of this, particularly for large whales in terms of ship strike risk in the New York Bight, now the entrance to the port of New York and New Jersey, the largest port in the United States, can't be understated. Particularly in an area, these buoys are situated just outside the seasonal management area, so they actually, when we do detect North Atlantic right whales, it helps trigger the voluntary requests for the NOAA slow zones, and in fact, the very first one, I think, Mark, if that's correct, was triggered from one of our buoys back in December 2020. And we've published that aggregate data about right whales in New York. That was presented at the last State of the Science as well. So the value of the near real-time nature here, both in terms of applied conservation, management utility, and education and outreach, letting people know about what's going on, can't be understated. But to kind of put this into some context for the rest of the symposium as well, is that I was thinking back to the progression of the work, here in the New York Bight. And when we first started working with NYSERDA in terms of the state of the science, a lot of what we did in 2018 through 2020 was based on knowledge in other areas. We were building up the knowledge in the New York Bight. We knew more about whales and dolphins in other parts of the country and other parts of the world than we did right here off of New York. And that started to pivot and change quite a bit when we got to 2022 and a similar symposium that we ran. It was initial. There was some initial synthesis of data collected, and again, just starting to see some initial aspects of that robust data set. And that brings us here to today, where Mindy's going to take a look at a deeper dive into 4 large whale species that we detect in near real time, but also through the passive archival analysis that's associated with the buoys. Mark is then going to take us through how real-time passive acoustic monitoring can be used to help mitigate risks for North Atlantic right whales, and what's the power and what are the challenges. And then Jen is going to tie it all together in terms of how Equinor and Empire Wind are using these data to make best practice and policy decisions around their development activities. So I hope you've seen the progression as we've gotten from 2018 to 2024. And with no further ado, I'm going to turn it over to Dr. Mindy Rekdahl, and then Mark and Jen, and then we'll have time for a panel discussion. So thank you.
Thank you, Howard, and thank you all for coming. As Howard said, I'm going to be taking a deeper dive into our long-term data set that we've been collecting within the Empire Wind Lease area in collaboration with Woods Hole Oceanographic Institution and Mark, and funded by Equinor and the Vettelson Foundation. Just before I start, I wanted to give a big shout out to our amazing team of acoustic analysts. Many of them are here. Thank you all for your amazing work putting all this data together and going through this incredible long-term data set. So the project, as Howard mentioned, has been running since 2016, but it's going to be ongoing until 2029, which provides an incredible pre-construction baseline or pre-construction information on large whale presence and distribution within the Empire Wind Lease area. We have 2 buoys which have near real-time and archival capabilities. The southeast buoy, which is located furthest offshore, was put in 2016, and the northwest buoy in 2020. We're focusing on the 4 large whale species: fin, humpback, North Atlantic right whales, and sei whales, but we are looking at other species as well, like minke whales, but it's only a short talk today, so we'll just focus in on those today. I'm going to be showing you a little bit of our archival analysis, and we've been using a combination of the LFDCS, or Low Frequency Detection and Classification System, and the CNN detector to go through that data. So many of you within the PAM community understand how much data is actually collected through passive acoustic monitoring. It's incredibly time intensive to go through, and there's many unknowns under the ocean. There's a lot of sounds, we just don't know what they are. And even for well-known species, we still have little understanding of their full vocal repertoire or the amount of calls that they produce. And Susan gave a great talk on this earlier with her acoustic tag data that really set up this talk quite well. So we tend to use automated detection methods to go through this large amount of data, and we tend to focus on stereotype calls of those species, such as the fin whale song, humpback whale song, North Atlantic right whale up calls. But all these species produce a variety of different calls, and they use those in different behavioural contexts, and that often has different seasonality for when they're producing those different calls. So incorporating all of these other call types really helps us to increase our chance of detection. So just to show you that a little bit with our data set as we're going through, this graph is showing an aggregate of percentage of days per month across both buoys and across years. And this is looking at detections of song. And then when we add in calling behaviour as well, we can see song is in blue here, calls are in the percentage of days of collection with both song and calls is in hatch colour, and then the calls is purple. So what we can see is they're acoustically detected year-round, but in late spring and early summer, or May to July, acoustic detections increase by up to 2 times when we include calls. So they're calling it more often during that time than they are producing song. And if you have a look at the pie graph over on the right-hand side, just overall, the days with only calls make up approximately 20% of acoustic detections. So if we're not including calls, we're underestimating acoustic presence. To look at the interannual trends in fin whale presence, we've got the northwest buoy on the the left-hand side of the screen, and the southeast buoy on the right-hand side. Song is on the top and calls on the bottom. What we can see is that there's basically a lot of yearly variability. We are seeing more detections on the southeast buoy than the northwest buoy, which tends to suggest the fin whales are a bit further offshore. And just to draw your attention to, for example, in 2018, that seemed to be a big year for fin whale presence in and around the Empire Wind Lease area. And just here in 2020, for example, there was more calling behaviour at this time. There was a peak in calling behaviour, and there was not as much song produced at that time. So just showing, again, how important it is to include multiple call types to really understand acoustic presence using PAM data. When we go to humpback whales, again, this is an aggregate over both buoys and across all years. Humpback whales are detected year-round. There's more overall acoustic detections in winter and spring when they're displaying song behaviour, which is their breeding display. But in summer and early fall, or June to October, acoustic detections increase by 2 to 3 times when we included calls. And overall, days with only calls make up, again, approximately 20% of acoustic detections. So again, it's important to include multiple call types to really understand what they're doing, and from a seasonal perspective as well. I will note here that we are seeing whales a lot more than we're hearing them in summer when we're out on the water. And a member of our team, Sarah, Trabu will be talking about this later today in the auditorium if you'd like to have a look at that. Whales don't seem to be as vocal here when they're feeding, so that's kind of feeding behaviour or feeding time when they're here over summer. They don't seem to be as vocal as in other areas, or at least we're not detecting them as much. So it just really speaks to the importance of PAM is not the be-all and end-all. Using other methods as well, such as visual methods, is really important. When we're looking at interannual trends in presence, again, we're just showing a lot of variability over time. We are seeing peaks in presence, but those peaks do tend to shift and change over time. Just drawing your eye to 2022 and 2023, for example, we can see there seems to be a lot of singing, a lot of song going on in those years. On to the right whales, North Atlantic right whales. Detections do definitely peak in winter and spring, November to April, which is when the seasonal management area designation is in effect in New York. But we are seeing detections in other months of the year, so they are detected in most months of the year in the Empire Wind Lease area. We did include other calls into this analysis, but at this point, so this, I should have said, this is just showing the up calls. We did include other calls as well, but we don't have a lot of confidence in those, in detecting those calls outside of when up calls are produced at the moment because of the overlap in humpback calls, so we need to know more about North Atlantic right whale other calls to increase our chance of detecting them. Just focusing in on the southeast buoy here for interannual trends, and we can see that there are clear seasonal peaks, as expected, but we are seeing in most years that we've been recording that there are detections outside of the peak times and outside of seasonal management area designations. So this means that we can't assume that North Atlantic right whales aren't going to be there. They may be there in all months of the year and at any time, basically. I also want to just point out here that, again, as has been noted, we were out on the water with North Atlantic right whales just last week in July, out near the Hudson Canyon, which will hopefully be designated as a national marine sanctuary soon. And this, we were out with 4 right whales, and this is in a separate area, of course, to the Empire Wind Lease area. But it just goes to show that they are out there in July. Things are always shifting, and it's very dynamic in New York. Just quickly to touch on sei whales. There's a low level of presence in all months of the year, but there were clear seasonal peaks in spring. Sei whales migrate, or are thought to migrate through the New York Bight in spring and fall, but presence in other months may indicate that there's some level of feeding, perhaps, going on in the New York Bight. And the interannual trends here, just something to point out is that on the southeast buoy, they tend to be have greater presence, and we did see this big peak in 2018, which seemed to be a good year for sei whales. So the take-home messages, what we have here is a really robust and continuous baseline data set, which is pre-construction within the Empire Wind Lease area. So by the time construction happens, there'll be 5 to 10 years of continuous acoustic monitoring data, which provides really important information on seasonal and yearly trends on large whales. And this is really important information to consider, particularly when we're thinking about implementing mitigation methods during construction. Multiple call types will increase our chance of acoustic detection to accurately document seasonal and yearly trends. So it's really important as we start to and continue to talk about this regional PAM network, as well as integrating other forms like acoustic tags is to collaborate and standardise species call libraries to help improve our automated detection methods. So that really helps to improve the utility of using PAM for broad-scale monitoring. Seasonal and yearly variability in presence with most species varied over time, but they were detected in most months. So we definitely have seasonal peaks, but they could be here at any time, basically, within the New York Bight. So this is really important information to consider when we are thinking about best practices around monitoring and mitigation during construction, because the New York Bight is a very dynamic system. Thank you.
Hi, everyone. My name's Mark Baumgartner. I'm from the Woods Hole Oceanographic Institution, and I'm going to talk about evaluating the efficacy of real-time passive acoustic monitoring near offshore wind energy development activities to help mitigate risk to North Atlantic right whales. It's a really long title. This work was funded by Equinor and the Huey W. Van Allen Clark Chair for Excellence in Oceanography. Okay, so I think we all have the same goal here, is to provide protections for North Atlantic right whales during offshore wind energy development activities that put right whales and other whales at risk of, say, hearing damage from noise exposure as well as vessel strike. And there's a lot of interest in using real-time passive acoustic monitoring to detect and localize whales to trigger dynamic mitigation action. So I've been working on this for some time now. I actually just last week submitted a manuscript to Endangered Species Research on this that has to do with both hearing damage and vessel strike risk mitigation, but for the purposes of today, I'm just going to focus on pile driving and level A harassment. That's permanent hearing damage. On the right is just to get you oriented. I'm going to talk about a risk zone that's 1.5 kilometers in radius around a construction site. That's my assumed area where level A harassment will occur. And then the bigger circle is a trigger zone, which is the distance within which a localized whale might trigger mitigation. And when I talk about mitigation here, I mean postponing pile driving. Okay, so we want to use PAM, but there's lots of questions about the implementation of passive acoustic monitoring, such as how many PAM stations do we actually need to put around a construction site? How far away from the construction site should they be? Should we be doing localization, or could we just trigger mitigation based on simply a detection? If we do localize, how far away from the construction site would the whale need to be to trigger mitigation? And once you trigger it, how long do you sort of keep that mitigation in place? Whenever I am faced with a problem where there's lots of variables like this and I just can't get my brain around it, sometimes simulations help. And that's what I'm going to do for this study, is simulate a swimming, calling right whale in a confined domain for a long time, and then set in that domain a bunch of different PAM configurations and figure out which ones work best. So in order to figure out what works best, we have to have some metrics to measure performance. So I'm going to measure 3 metrics in these simulations. The first is the probability of missed mitigation, which is how often does a whale enter the risk zone in the simulation, but mitigation is not in place at that time. This is a really important one. This is the metric that tells you how protective a system is for right whales. So how well does it both monitor and implement mitigation or trigger mitigation? The second is how often is mitigation triggered. That's in the simulation, what proportion of pile driving sessions were actually postponed. The last metric is the probability of false mitigation, and that is how often is mitigation triggered, but the whale doesn't actually enter the risk zone during the mitigation period. Now, I've given 2 talks on preliminary results from this study, and if you've seen those talks, keep paying attention, because I paid a lot of attention in those talks to the probability of false mitigation. And I think that focus on probability of false mitigation was misplaced. I think what's probably important in terms of cost to industry is the proportion of pile driving sessions postponed. It kind of doesn't matter whether the whale actually shows up or not, because the damage is done to industry. You've already postponed the pile driving. It does matter because you want this system to work well. So I'm going to use that as an important metric. Okay, so how do we choose the best PAM configuration? I'm going to use a maximum allowable probability of mismitigation to cull the simulations that don't provide sufficient protection for right whales. Again, the probability of mismitigation tells you how protective the system is, and I'm only going to pick the ones that are decently protective. Well, what's decently? I'm going to define that as setting this maximum allowable probability of mismitigation to a threshold of 0.15. And that 0.15 assumes that there will be other monitoring modalities. We'll talk a little bit more about that at the very end. Okay, for the simulations that actually satisfy that threshold, let's choose the one that costs industry the least. And cost here is going to be measured as the proportion of pile driving sessions that were postponed in the simulation. But it's also important to keep in mind, because they do have costs associated with them, the probability of false mitigation, number of PAM stations, and the complexity of those systems, i.e. the complexity of the alerting method. Are you doing localization or are you doing detection only? So here's what the simulation looks like. On the right-hand side, I'm showing a map. Basically what I'm going to do is have a virtual swimming, calling right whale swim around this 80 by 80 kilometer domain for 10,000 days. The movement behavior is parameterized by values that can be found in the literature after the approaches by Julie Vanderhoop and Hansen Johnson, and the calling behavior is parameterized by the work of Susan Parks. The PAM stations have the chance to detect any call that this virtual right whale makes using the detection function, that is the probability of detection with range, that was measured empirically through the work of Hansen Johnson in a recent paper. I'm going to assume that pile driving occurs once a day for 3 hours, commencing at noon, and I'm going to run this simulation 100 times. I'm going to measure all those metrics that I just talked about, and I'm going to run the simulation 100 times so I get an understanding of the variability in those metrics. From one simulation to the next, I'm going to change things, and I'm going to change the PAM configuration, that is the number of PAM stations. I'm showing 4 in this, but I varied it from anywhere from 2 to 8. The distance of the PAM stations from the construction site, between 5 and 20 kilometers. We're going to test whether detection only versus localization works well. And then I'm going to vary what I'm calling the mitigation rules. That is, how far away does a whale have to be to trigger mitigation, and how long do you keep that mitigation in place? And as I just mentioned, for each one of those simulations, I'm going to measure each one of these metrics, and then I'm going to do the simulation 100 times to get variation in those, to assess variability in those metrics. Okay, so let's go right to the results. I want to remind you this is just for mitigating the risk of level A harassment, that's permanent hearing damage. And on the left, I'm reminding you of the things that I changed, the variables that I changed in each simulation. And then you'll notice that the first couple of columns in this table are those variables that I changed, and the last 3 are the numbers for the 3 metrics. And I'm going to walk you through this table. So there were 255 simulations in total. Of those 255, only 36 had a probability of mismitigation less than 0.15. So as the way I've set this up, only 36 of the 255 were protective enough of right whales. I took those 36 and I ordered them by the cost to industry as I measured in proportion of pile driving sessions postponed. And what you're seeing are the top 10 simulations ranked with the lowest proportion of pile driving sessions postponed. Okay, so let's walk through it. So you'll notice that not only these 10, but all 36 of the simulations that had a decent probability of mismitigation had very high probabilities of mismitigation. I don't have time to go into why that is, but it boils down to the fact that you have a precautionary system, an animal that moves around fast and doesn't call very often. That produces a high probability of false mitigation. The proportion of pile driving sessions postponed range between, I'm going to need my glasses for that, 17 to 32% of pile driving sessions in the simulation were postponed. Now that might sound like a high number to you, so let me say it a different way. 68 to 83% of the pile driving sessions in the simulation went on as scheduled when a right whale was nearby. Remember, I've trapped a right whale in this 80 by 80 kilometer domain, so there is always a right whale within a few tens of kilometers of the construction site. Despite that, 68 to 83% of the pile driving sessions were allowed to go forward in the simulation. If you want to do localization, that's great, but it'll take quite a few PAM stations. The best simulations with localization had 6 to 8 PAM stations placed 15 to 20 kilometers from the construction site. If you want to do detection only, meaning any of the PAM stations, if any of the PAM stations detect a whale, you implement mitigation. You can do this and achieve this probability of mismitigation less than 0.15 by only using a few PAM stations placed much closer to the construction site. I'm just going to focus in on 2 of the best performing configurations. Involve 3 PAM stations placed 5 to 10 kilometers from the construction site using detection only alerts, and the mitigation duration was 12 hours, meaning you only had to monitor for right whales 12 hours prior to pile driving. Okay, for those 2, roughly a quarter of pile driving sessions were postponed in the simulation. Another way of saying that is that 3/4 of the pile driving sessions went on as scheduled when a right whale was nearby, which was always in the simulation. Okay, the last thing I'm going to talk, this last slide I'm going to talk about is there's a lot of interest in combining monitoring modalities to kind of do a better job of trying to catch when right whales are near or in your risk zone. And so what I'm going to talk about is sort of a quantitative way to assess how well those systems will work together. So let's say we had a monitoring plan where we had a PAM system and then we had visual observers on the pile driving platform. You can use the simulation techniques that I just described to estimate the probability of mismitigation for each one of those monitoring methods independently. And then all you have to do is multiply those 2 things together to get the overall probability of mismitigation. In other words, in this case, the probability that a right whale will show up in your risk zone while pile driving is happening is, and both of the systems, the PAM system and the visual observers, miss that animal, is 0.0075. The nice thing about that is you can take that overall probability of mismitigation and compare it to a maximum allowable probability of mismitigation that should be set by the regulatory community to basically approve your monitoring and mitigation plan. This way, the government doesn't care if you're using 4 or 12 PAM stations. They don't care about your detection range. All they do is set the minimum level of protection for right whales with this maximum allowable probability of mismitigation, and the developer has the responsibility to put together a monitoring plan, evaluate it in this way, and say, yeah, it's going to meet that maximum allowable probability of mismitigation. Okay, so just to wrap up, I found that PAM stations can achieve good probabilities of mismitigation and modest impact to pile driving operations with a few PAM sensors doing detection-only alerting method, which reduces cost and complexity. PAM should be combined with other monitoring modalities, and when it is, it can be an effective contributor to those systems. And finally, this will require regulators to think about and set these thresholds of maximum allowable probability of mismitigation for each risk. I want to thank members of the expert panel that Equinor put together to help them think through marine mammal monitoring, and thanks to you for your attention.
All right, well, thank you so much, Mindy and Mark and Howard, for setting the stage there. So my name is Jennifer Dupont. I'm the head of technical environmental affairs at Equinor, and I'm going to try to tie all this together and just give you a bit of information about what we're planning for our monitoring and mitigation program, thanks to all the efforts of the amazing scientists that we have on board with our expert panel and the work that we've been doing over the last couple of years. So for those of you that aren't familiar, Equinor is a broad energy company. We're based in Norway, but we have been in the U.S. for the past 35 years with offices in New York and Connecticut and down in Texas as well. We have been developing offshore energy projects for the past 50 years, and the last 10 years there's been a large focus, obviously, on the offshore wind projects. So you can see up here some of the ones that are in operation. Most of these are in the North Sea, in the UK, that we've brought online and had actually operating there. And then we are building our Empire Wind project. We've started construction there this year, and we'll do foundation installation there next year. And we also hold a lease out on the West Coast as well. The Empire Wind project, I think you saw a few of the maps of where that is. It's about 15 miles south of Long Island. There's going to be 54 15-megawatt Vestas turbines that are constructed there, and 810 megawatts of installed capacity once we're up and running in full operation. We are using monopiles. I'll show a couple of pictures of that, and so that's why there's been a lot of focus, as you see, on actually designing a monitoring and mitigation program to protect the animals, because there will be noise that is generated as a result of all our pile driving activities. And we do have an offshore substation and then inter-array cables that connect the turbines and then come in through a 250 kV export cable that's coming into Brooklyn. So we're revitalizing a port down in South Brooklyn, at the South Brooklyn Marine Terminal near Sunset Park in Industry City, to have our operations and maintenance base as well as our onshore substation. And then we connect into the grid at the Gowanus substation in Brooklyn. And so the operational lifetime for this project is 30 years. And you can see some of the renderings there on the bottom of the 39th Street Pier that we are currently actually constructing on. You'll see here a picture of our groundbreaking ceremony that we had about a month ago now, and a few of my colleagues, my permitting colleagues, got to go down and see all the great work that Skanska is doing there. I took that picture on the bottom left from up in where we're building a learning center for the community, and then you can see how the operations and maintenance base on the right side is being rendered with green roof, wedge certification, waterfront alliance, and this is where we'll be staging the large components to actually go out and install this. And the offshore installation will start in May of next year. So we're currently building and reinforcing those piers to be able to hold one of the biggest cranes in the entire world and lay down all of these components. And then we will start the foundation installation in May 2025. We're currently building, or Vestas is currently building the nacelles and the turbine components for this. And here's just a picture of the monopiles that are currently being fabricated as well. I think myself, working at an engineering company, I am in awe of the scale of what we are trying to build here. We are trying to solve, obviously, one of the biggest challenges of humankind when it comes to climate change and transitioning an entire energy system. I think New York is at the forefront of making sure this happens. And so in order to help to actually build and move into the energy transition, large infrastructure is needed. And so I think my reaction, again, being on the developer side, is to be in awe of our engineers and what we're capable of building. But I also know that there's definitely the environmental side of me that's like, how are we going to protect the environment while we do that? And that is the really big question here, right? How are we going to install these large offshore components while we protect the marine environment? And we're not going to use these kind of tools. We're going to use a bigger version of them. But I think there's some key things that I just want to make sure that this audience knows as well. And I'm sure there's a lot of you that are familiar with it, but for those that might be newer to the industry side, we have an incredibly robust and consultative permitting process. Again, I have a number of colleagues here from Equinor, and I know from the other developers that work this Since 2017, when we acquired the lease, we've been working this permitting process and are only starting offshore construction next year. So you see it's an 8-year process that has been incredibly robust as we move forward, and we thank all of our regulatory regulatory people as well. We have set up the independent academic expert panel, so that's what Mark was referring to. Howard and Mark and Doug Novacek and some of the colleagues from University of New Hampshire have also been part of that panel to help make sure that we are continuing to be at the forefront of the science and bring in those lessons learned as we are developing our monitoring and mitigation programs. There have been other projects, Vineyard, South Fork, Rev is going right now, and other developers that are currently putting steel in water, and we are continually thankful for the communication that we have with them so that we can continue to build and learn and incorporate lessons learned as we go forward and get ready for our installation next year. Again, the continual internal and external review, development, testing, and deployment of best available technologies. I think that the work that Mark has submitted and published is, a culmination of so much work and rigorous scientific expertise that we are also incorporating into our plans. And then as we move into execution, the focus on compliance, but also adaptive management. Stuff will go wrong out there, and we need to work together with NOAA, with BOEM, with Bessie, with our experts in order to adapt and make sure that we are continually protecting while we install these large components. So where are we at now? We have our letter of authorization, and we're designing our program, and I just want to flash this up to give you a sense of what we are working with as we move into next year. We have that seasonal pile driving closure that Mindy referred to from January to April, so we will not be pile driving at that time. But as we saw from the data from the PAM buoys, there are whales there at all times. So we need to make sure when we are actually installing that we have the proper mitigation components in place. So we are going to be placing acoustic monitoring PAM buoys around each pile. We're still working with the expert panel on the exact number, using Mark's recommendations, doing that cost-risk analysis. Currently thinking, as you can see in this graphic, 4 of these that are placed in order to monitor as we go forward. Protected species observers, we have a minimum of 6 NOAA-approved PSOs that need to monitor and document the marine mammals, with 3 of those that need to be on our installation vessel. So you can kind of see that in the middle platform with the 3 little dudes or ladies or whoever it is that are right on there. And then the other ones will be on a vessel monitoring the area around as well. Then the clearance and shutdown zones, which depend on species, that will be monitored and activated as needed, depending on these observers and our PAM buoys. And then you can see there right in the middle, we do have that double bubble curtain requirement. So that's a noise abatement technology to actually absorb some of the noise around the pile. We basically put the bubbles up from the bottom, and that surrounds the pile and absorbs the noise. We will be employing soft start, so that is just starting obviously a bit softer and allowing the animals to move out of the way if they happen to be there, if we haven't seen them. And then the infrared cameras are an additional technology that we will be using. As we heard from Mark, the PAM and the acoustic buoys are obviously fantastic technology, but we need to have the visual observations as well. And we've been using a Toyon infrared camera, the WhaleCam 66, that we will deploy on the installation vessel as well as on that PSO vessel to augment the PSOs, to have them be able to use that, and also to help with some of our lower visibility conditions. In addition to the pile driving, we do have vessel strike avoidance mitigation measures. So all of our vessels associated with the projects will be traveling at less than 10 knots. We have a large training program for all of our crew members. The vessels will have dedicated visual observers on duty at all times to monitor for marine mammals. And then we have a variety of separation distances that we're currently working through, again, with the regulators in terms of our vessel strike avoidance plan, which we are submitting, working through with NIMPS and BOEM and Bessie as well. So just to conclude here, you know, I think that everything that we heard from Mindy and Mark and from Howard, it's really all culminating into what we hope is going to be an incredibly, you know, protective program, and that we are able to get these foundations installed next year, and start generating clean energy for the state of New York as soon as possible. And our commitments is really around being these 4 values that we have at Equinor: open, courageous, collaborative, and caring. And I really very much appreciate all of the insights and the work that the expert panel has provided with us, and for the chance to speak with you all here today. Thank you. I'm going to get rid of this somehow.
All right, we're going to move into our panel discussion. Thank you for a series of great talks, and there's a lot of great questions. We're going to do our best to get to as many as we can, so we're going to do a rapid fire. Mindy, we're going to start with one for probably you and Mark. Mindy's presentation showed it's important to consider additional types of vocalizations when assessing acoustic presence. What are the prospects for this being automated and implemented coast-wide? I think both of you could probably, you know, speak to some of that. So,
yeah, it's on. Sorry, could you repeat the question? Sorry, Howard.
So, additional types of vocalizations when assessing acoustic presence. What are the prospects for this being automated and implemented coast-wide?
If we're talking about archival, and I'll let Mark talk about near real time, but I mean, I think we're starting to improve our automated detection methods with whatever we're using. So I think the more information that we have about these, about their call repertoires, we can really start to build those call libraries that can be fed into those automated detection methods. So I think there's a lot of information out there that's being gathered from acoustic tags, for example, that provide incredible amounts of data on their call repertoires. So we just need to gather all that information into one place, and then we can start to use that to feed into our automated detection algorithms and methods. Do you have anything to add, Mark?
No, not really. I mean, one of the things we're challenged with is there's lots of sounds that are made in the ocean, and we don't know who makes them. And so attributing sounds to particular species is really both really, really important and also really, really difficult. And so, yeah, that's part of the issue. Another part of the issue is just how often and how easy those sounds are to detect. For instance, right whales, as Susan pointed out this morning in her great talk, right whales make a whole bunch of different sounds, but they do them in social contexts, and their production rate is really variable compared to the upcall. The upcall is made by both sexes, and it's done mostly, we think, as a contact call, and so they're using that a lot, whereas they don't use the other ones as much. The gunshot we could use, but that's a totally different kind of sound than an upcall, and so we certainly could try to develop detectors for that, but we haven't.
Great, we're going to keep it going. Mark, I'm going to stay with you, and we're going to just kind of hit them as fast as we can. Generally, how often do construction activities have to pause for marine mammals entering the trigger zone? Do we have observed data on this?
No, that's why I did a simulation, is because getting those numbers are almost impossible to do. Okay,
we'll stay on this one. Just Mark, you listed the.
Before you finish that, Howard.
Okay.
We can collect that data though, because if someone's pile driving and you have observers out there, you should be keeping track. It's really important that the people that are collecting the data for mitigation during pile driving exercises, that data is saved so that it could be analyzed afterward. It would be really useful to know how often right whales do come into the risk zones. My simulation suggests that it's going to be very rare for a right whale to show up, because the level A risk zone is tiny. And the period of time during which pile driving occurs is also relatively small. It's only max probably of 3 hours out of the day. That's a very small window in a very small location for a right whale to show up. But we should be collecting that data during construction activities to figure that out.
Yeah, these are good warm-up questions. We're going to get to some thorny ones in a bit, guys. So Jen, you get your warm-up question now. Okay. What role could BOEM play in facilitating collaboration and standardization in this area? Could requirements be added to the permitting process? I ask you from your perspective.
Yeah, and I think that they are. Like one thing that we were just talking about at lunch, right, was our long-term PAM plan that is one of the requirements in our COP approval. I think that what we're getting to right now through the Regional Wildlife Science Collaborative, BOEM, all of these efforts around regional approaches to this and standardization, I think we're there. I was mentioning at lunch, it feels a little bit like being on the Empire side where we're getting ready to install next year. We're almost ahead of the game and like paving the way for that. And I think in 4 or 5 years, this is all that there'll be much more standardization in place, but we're just in that phase right now. And I know my colleagues at Vineyard and at South Fork and others are feeling that when you're one of the first movers, you feel like we use the analogy of building the plane as we're flying it all the time at Equinor, and it feels a little bit like that, but all of this, to Mark's point, we are collecting data. We can now start analyzing. What Equinor and Ørsted and others bring is also the experience from Europe, right, on what's worked and hasn't worked there. So we are bringing all that experience, but now with the context of these large baleen whales, which is the difference then compared to our European projects, we are going to have the data and we will be contributing to that process. But BOEM, NOAA, everybody has a huge part to play in this.
So Jen, we're going to stay with you, but before I ask my next question and we get into some really meaty questions, if there's anyone from NOAA and BOEM, note to self for future that might want to join the panel for some of these next questions, feel free to step up. Don't be shy. Yeah, put you on the spot. I'm sorry. But Jen, we'll stay with this one. How is Equinor and industry sharing the info and pile driving mitigation with the public? The graphic in Jennifer's presentation was very helpful.
Yeah, no, and that's taken right from one of the fact sheets that we have on our Empire Wind website. So if you want to go and check that out, we're going to be continually updating that. I'm on a big kick of getting better about fact sheets, representations, videos, et cetera, to make people understand what it is that we're doing and what we're not doing. And I think that our other developer colleagues are there as well. I just think we can be better about communicating that. There's a lot in terms of sharing externally, but also being cognizant of our permitting process and making sure that we are developing this in the right timeline that comes about. But I think that graphic you can go find on our Empire Wind website, and we're happy to continue to develop that.
So this is my next question. It's one of our top vote getters, and it may be a tricky one for the panel, and that's why I invited a colleague from NOAA or BOEM to feel free to join in to the party, because inquiring minds want to know. Has there been any discussion about why NOAA and BOEM are requiring real-time PAM, the picket fence for offshore wind vessels, to go less than 10 knots when they don't require the same for cargo and commercial vessels? I think the person asking this meant less than 10 knots. So I don't know if our panel feels they want to ask that, or if a select member from the audience would like to participate, but we will maybe come back to that one. So, but we can ask this question while we think about that, and maybe if someone decides if they're going to step forward. A big topic. Is there any data supporting the slow start pile driving effort actually mitigates impacts to marine mammals or other critters? So they're asking for any evidence on that. So would you be able to share that?
I would probably, I don't know if anyone from Vineyard or from the other developers is here. I guess my experience is that this was a pretty effective mitigation measure from the oil and gas side, right? From when we're doing, full disclosure, but prior to joining Equinor, I worked for 12 years for Exxon. So I worked quite a bit on oil and gas projects where we had to sound and marine joint industry program that was very focused on what sounds from the industry. Seismic is obviously, a low frequency, very high energy source, and that soft start and ramp up of the seismic was a very effective mitigation measure. And I think we're trying to translate those learnings into the offshore wind space with the pile driving and other low frequency, high energy sound. And so that starting off, the theory is there of starting off and putting lower levels of sound into the water to move the animals out of the way and then ramp up. And so to the actual empirical efficacy of that for offshore wind, I don't know if anyone else has any of those data. I'm not quite aware, but I think that the theory should hold.
Can I answer the previous question?
Yeah, go for it.
Do you really want to hit a right whale? Do developers really want to have, say, a vessel that's servicing the Equinor wind farm hit a right whale, and then that goes into the news? Does anyone really want that? So a way to ensure that is to go 10 knots or less. Now, I'm not answering the question as to why NOAA or BOEM are requiring that. I don't actually know if they are. But man, it's in your interest to go 10 knots or less.
Yeah, and to that point, I think it's any large whale, right, in the New York Bight. We see, how valuable and the importance, communication and efforts can be to get the science right about this. So the effective mitigation that we have is going slow in what is now amounts to be the busiest port, in the U.S. So it takes a village, right? No one is off the hook. It's every sector. So I think, while this is really a question for NOAA and BOEM, we all have our in essence, our feelings on this. So,
sorry, I'm gonna I do not want to hit it right well, absolutely.
Yeah.
But here's the thing, right? Like, I think that the issue and where the crux of that question is that the offshore wind industry is held to a very different standard than any other maritime user, right? So if we're going to go less than 10 knots. If we weren't to do that, we would have to put out PAM buoys to clear the transit corridor to get out to our offshore wind farm, whereas every other vessel in the area can blow through at 14 knots or whatever it is. And there's also safety implications as you're coming into New York Harbor with pilots that need to come on board and to keep up with traffic. So there's a lot of nuances to that, and I'm assuming the person who asked that question is probably leading to why is offshore wind different and what does that look like, in the future, which is something we're all talking about. What is the right answer? Because we are a very, very small % of the traffic out there.
And we've had this discussion. This could be like a whole symposium of itself. And I think the most contentious discussion maybe that we had in NYSERDA E-Twig dates back to, when we were dealing with BMPs, and some of you in the room were part of this, right? And there is a paradigm, a precedent setting, but it only really works if the whole community, all the marine resource users, participate. And that's a fair point. I think we're going to pivot back to some other questions. Mark, there was a question for you. I lost the question, but in essence, it was around what we know about bowheads in the Arctic, and there's good data that animals either deflect or decrease their rate of calling from seismic sounds, and that's what was behavioral response incorporated into your simulation, and if not, what effect do you think it would have?
Yeah, we're at time, right? 2:30. So
we are at time, so maybe
I'll make it really short. I didn't include that in the simulation because I didn't want decisions about monitoring and mitigation to rely on a whale's specific behavior. Like, we shouldn't put this on the whales to get out of the way. So I didn't include that in my simulation.
Okay. And if we have time just for one more question, I want to give Jen, I think this is a fair tee up for you. Has there been any disagreement or conflict within the advisory panel, and how is that resolved? And how are the cost elements of the recommendations assessed? So if you can bring that all together and close out our session, Jen, that would be great.
I think there's been really constructive debate and healthy debate, and I would defer to you two to tell me if not. And I think it's just an ongoing relationship and a great model that's been working really well, and we look forward to continuing that relationship.
So we thank you all, and I think that was a good way to end the session. I think it does take, in essence, all of us participating in dialogue, and we may not always see eye to eye on everything, but we based on the best available science, we try to work through it. And thank you all for coming, and we look forward to the next sessions.